Good morning to all of you. Today I am recording the video lesson for the day 3. Today I am going to teach a lesson on the simple processes and chains along with some examples. And for this, today I prepared a PPT presentation that will be shared to you. Now I am starting the lecture with the help of the PPT. I am Dr. M. SRINIVASULU, Head of Section in Mechanical Engineering, working at Government Polytechnic PARKAL, and I am going to teach a lesson on the solid mechanics. The topic is simple stresses and strains. So in the previous class, we have been discussing about the stresses and strains with the formulas and the modulus of velocity and the Poisson's ratio. Here, for our just recapping the previous class, the formula for the stress is equal to load by area. Stress is defined as the load acting on a body per unit area. Stress F is equal to P by A. The strain can be defined as the ratio of the change in length to original length. And the strain E is equal to delta L by L. The delta L is the change in length and L is the original length. And when a body is subjected to the tensile force, the delta L is positive, and if the body is subjected to the compressive forces, then the change in length will be negative. So the strain will be positive in case of the tensile stresses, and the strain produced will be negative in case of the compressive stresses. Now the next one is the Young's modulus. Young's modulus can be defined as the ratio of the stress to strain. E is equal to F by E. And the next important term is the Poisson's ratio. Poisson's ratio 1 by M is equal to lateral strain by linear strain. The strain obtained in the direction of the force applied is called as the linear strain, and the strain obtained in the lateral dimension, that is perpendicular to the force application direction, is called as the lateral direction, and the strain produced in that direction is called as the lateral strain. So the ratio of the lateral strain to linear strain is called as the Poisson's ratio. So these things we have discussed in the last class. Now coming to the present class, so we are going to discuss about the mechanical properties of a material, and also along with some problems on the stresses and the strains. So these we are going to discuss. The first one is the mechanical properties. The selection of a material for any application in the engineering depends on the mechanical properties. So the mechanical properties play very key role in selecting a suitable material for a correct design and for a particular purpose. Now, so we got the different mechanical properties, out of which the following are the important, like strength, modulus of velocity, ductility, and malleability, brittleness, hardness, resilience, toughness, particle strength, creep. So these are the various important mechanical properties of a material to be considered for the for a member to be selected for a specific application. So we'll discuss the properties one by one. The first one is the strength. The strength means what it is, nothing but the strength can be defined as a ability of a material to withstand the external loads without failure. The ability of the material to withstand the external loads without failure is called as the strength. So, of course, our subject solid mechanics or the strength of materials, nothing but the name came by this property. Because in all the cases, first of all, we will select the what is the strength of a material, and based on the strength of the given material, we will select that one for the suitable purpose. The strength is a very common property, and it is a very important property to be taken into consideration before selecting it for any application. And the strength can be defined as the capacity of a material to withstand the external loads without failure. And so if you see the strength, the generally the mild steel, I mean the maximum strength as compared to the cast iron and other materials. The second one is the modulus of velocity. So this is also a very important property. It is also called as the Young's modulus. So it is nothing but the when a body is subjected to some kind of stresses, maybe either tensile stresses or compressive stresses, the ratio of the stress to strain obtained is called as the modulus of velocity. So whenever the most important condition is that the material must be strained within the elastic limit, because the Hooke's law must be followed. The Hooke's law is applicable only when the material is strained within the elastic limit. So that is the condition. So whenever a body is loaded within the elastic limit, some kind of stresses and strains are produced. So the ratio of the stress to strain is called as the modulus of velocity or Young's modulus, and it will play a vital role in selecting the materials for the different applications. So out of if we take cast iron, copper, gold, silver, and mild steel, the mild steel is having the highest value for E. Generally, the E for mild steel is about 2.0 into 10 power 5 newtons per square millimeters. And if the material is having the good strength, then the modulus of velocity value will be higher as compared to the weaker materials. And if the modulus of velocity value is more, then automatically the stiffness value also more. And the stiffness is nothing but it is the measure of deflection under load. If the material is strong, having the more strength, then if you apply a load, it will not deflect much amount. The deflection will be minimum. When the deflection is minimum, then the stiffness value is maximum. Automatically, the Young's modulus value also maximum for that. The next one is the ductility. So this is also one of the important property. So this property plays an important role in drawing the wires. So a material having the ductility property, more ductility with more amount of ductility property is suitable to be drawn as wires. So generally the mild steel is the most ductile material, one of the most ductile material. So therefore the nails can be made by wire drawing with the mild steel material. So if this ductility also can be found by conducting the tensile test on a specimen, given specimen. And if the percentage elongation is more than 5, we can say that ductility is, the material is said to be ductile one. If the percentage elongation is less than 5, then it is said to be not a ductile material. And this the next one is the malleability. So this malleability is the other property. So this due to this property, the material can be produced in the form of sheets. Here the compressive load is applied. If when a material is subjected to compressive load, it will elongate or the thickness reduces and surface area increases. That is, it can be formed into the thin sheets. So this material helps to form the sheets, and generally the brass, bronze, aluminum are having the malleable properties, and therefore the sheets can be drawn from those materials because those materials are having the more malleability property. So malleability can be defined as the ability of the material to be deformed into sheets under the action of the compressive load. When two equal and opposite pushes are applied, automatically the material is under compression and it can be rolled into the thin sheets. So this property is called as the malleability. So gold, silver, aluminum, and brass bands are having the malleability property. And because of this property only, the materials are formed into the or rolled into the thin sheets. The next one is the brittleness. So brittleness is nothing but it is the ability of a material to fracture under the action of the load without much deformation. That means the material will be broken into the two parts with a very little amount of force. Here what is happening is the material is unable to resist the deformation produced with the force. When it is unable to resist the deformation, automatically the fracture occurs. And due to this property, the material can be fractured into the parts without much amount of load. And the brittle materials are having the low percentage of elongation. Now coming to the engineering applications, the cast iron is one which is having the more brittleness as compared to the other materials. So the cast iron cannot be used for the applications where the high strength is required, where it is subjected to the tensile stresses. Only it can resist the compressive stresses. When it is subjected to tensile stresses, automatically it will break with a little amount of tensile stress. Therefore, the cast iron is one of the brittle material, and it can be used for the basis for the missions. So because the cast iron is having the very good casting properties, and we can able to easily mold it. Due to that one, so the mission bases, because the base will not be subjected to the tensile forces, only it will take the compressive forces. The basis of any mission can be made with the cast iron. And the next one is glass and other materials are very brittle, and they will simply fracture without much amount of load application. And even this brittleness also can be decided by conducting a tensile test. If the percentage of elongation of a material is less than 5%, then that material can be decided as a brittle material. The next one is the hardness. So it is one of the important property of a material, and it can be defined as the resistance offered by the material to penetration, indentation, scratching, or cutting. That means if some tools are applied, if the material is having low hardness, means the depth of penetration is more. If the material is having high hardness, means the depth of penetration will be less, and it can be measured by conducting a hardness test. So generally we got the Rockwell hardness testing emissions and Vickers hardness testing emissions, and the basic principle of the testing is, here the material is subjected to indentation by applying standard load. Then the depth of penetration can be measured automatically by the machine, and based on the depth of penetration, the hardness of the material can be decided by a number. So generally 80 BHN, 100 BHN, that is the 80 Brinell hardness number, 100 Brinell hardness number, like that they will be specified. And anyhow, if the material is having the ability to withstand the abrasion, cutting, or indentation, then the material is said to be hard one. Otherwise, it is regarded as a softer material or the material with low hardness. Here, once again, the hardness can be defined as a property by which the material offers resistance to indentation, penetration, scorching, or cutting. And if you see, the hardest material in the nature is diamond. That is the nature material, and artificially we got stellates, carpets, like that. We got so many materials now. We got the hardest one, and this hardness of a material plays a very important role for selecting the application of that material to the various applications. For example, uh, for a material to be selected for a cutting tool, this hardness is the one the foremost property required for a cutting tool. The cutting tools are made with only harder materials. Like we know the what are the, so some of the examples of the harder materials are what? Tungsten carbide, stellites, high carbon steels, like that we got to. So those materials are selected to make the cutting tools as the very less, and it could able to cut the other materials. The next one is the resilience. So it is defined as the ability of the material to store the energy within elastic limit when it is strained within Hooke's law. when it is strained within elastic limit. So this UXA is applied to the resistance, and within elastic limit, any material is strained. The amount of energy stored in that material is termed as the resilience. So in this resilience, it should not produce the permanent, because within elastic limit means the when it is strained within elastic limit, the material will regain its original shape and size after removal of the applied load. So therefore, so it will not produce the permanent deformation. So whatever the deformation produced, that is only elastic deformation. And after removal of the load, it will regain its original shape and size. So the amount of energy stored within elastic limit is called as the resilience. And so with this, so generally the resilience more, then it will store the, it will able to store the more amount of energy when it is strained within elastic limit. And it is one of the important and desirable property required for making of the parts of a mission which are subjected to impact loads. For example, the connecting rod of an IC engine, the crank of a IC engine are subjected to impact loads or sudden loads. Therefore, while selecting the material for making of such parts, then we should take into consideration of the resilience of the material. The next one is the toughness. So it is also one of the important material property of a material, and it can be defined as the ability of the material to absorb the energy before fracture. So the ability of a material to absorb the energy before its fracture is called as the toughness. And so generally, the if a material is having the highest toughness, will produce the less deformation when it is subjected to some kind of external load. And this is the due to this property, the material will not fracture, but it will deform plastically under the load. The brittle materials will have only less amount of toughness, and due to that only they will brittle, they will fracture immediately. And if the toughness is more, then the material will not fracture, even it could able to absorb the energy to the highest load. So the mild steel will have the more toughness value as compared to the cast iron, and so the cast iron will break easily, and it is called as a brittle material. And whereas the mild steel will absorb the more amount of energy, and it will not break, and it produces whenever it is subjected to some kind of load, it will deforms plastically rather than breaking. That's why it is the toughest material as compared to the that of the cast iron. And it also plays important role while selecting the material which are subjected to the impact loads or the sudden loads. The next important property is the fatigue strength. So the fatigue strength is nothing but it is the ability of the material to resist the cyclic loads. What is this cyclic load? The magnitude of the load continuously changes. For example, like it will go like a sine curve. It is starting with 0 and reaching to the maximum value in the positive direction. After reaching the maximum value, again it reduces to the 0. And after 0, again it goes into the negative direction. So it reaches to the maximum value in the negative direction. Then afterwards, it will again increases and coming to the 0 value. Like this, it comes to cycle like a sine curve. So the magnitude of the force continuously changes with time, then that force is called as the cyclic force, or that is a cyclic loading, and that is also called as the varying loads. And here this is so the ability of a material to withstand the cyclic loads is known as without fracture. The ability of a material to withstand the cyclic loads without fracture is called as the fatigue strength. And this fatigue strength can be found by conducting a test, and we'll have the endurance limit, and we'll have some number, and this endurance limit here, uh, endurance limit also, or the fatigue strength also plays a important role while selecting a material which are subjected to cyclic loads. For example, the connecting rod of an IC engine. So in case of a connecting rod of an IC engine, continuously tensile and compressive forces are coming on the connecting rod, and it is subjected to the positive and negative forces, and continuously the magnitude also varies and direction also varies, and so the connecting rod can be made by a material which is having the more fatigue strength. The next property is the creep. So creep also one of the important property. So it can be defined as the slow and progressive deformation of a material with time at constant stress is called as the creep. So that means the deformation with, so whenever a body is subjected to some kind of load, a continuous load, so the deformation slowly occurs. If the load is acting for a continuous for a long time, then it deforms. So the slow and progressive deformation of a material with time at constant stress, or that constant load, at constant load is called as the creep. And this creep is one of the important property to be selected while designing the furnace applications. Now we'll here the properties that we have discussed. Next, we're going to have some simple problems on the simple stresses and strains. So this is the first problem. Now the first of all, the student has to write this problem, then we can have the solution. A steel rod 20 mm diameter and 600 millimeters long is subjected to an axial pull of 40 kilonewtons. Determine the elongation of the rod. If Young's modulus capital E is equal to 2 into 10 power 5 newtons per square millimeter. Now this is a simple problem, and we are supposed to find out the elongation of the rod due to the application of the force given. So here, before solving any problem, it is very important that first of all we should write down the given data. The given data will tell you, first of all you have to arrange the data given in the problem. You have to read carefully and arrange the data in order. The next thing is conversions. For example, sometimes the meters are given, sometimes millimeters are given. Generally, we have to convert all the dimensions into the millimeters and newtons if it is a force. So that part, so we have tried on the given data, then we have to simply convert that millimeters, meters into millimeters, and kilonewtons or any other unit into newtons. Like that, we have to simply do it like that. Then that is nothing but arranging a data in a planning manner. So now you see the given is the diameter, the rod is having a diameter of 20 millimeters. Therefore, the cross sectional area A is equal to pi by 4 into d square. That is pi by 4 into 20 square. It gives 314.16 square millimeters. The next, the length of the rod is given directly, that is equal to 600 millimeters. L is equal to. Next, the axial pull is given. That is a pull type of force. This it is subjected to pull force. That is, the body is subjected to a tensile force of 40 kilonewtons. That is 40 into kilo means that is suffix 10 power 3 thousand newtons. So 40,000 newtons. That is the force. Next, the Young's modulus is given. E as 2 into 10 power 5 Newton per square millimeters. No need to convert. Next, so we have to, firstly we have to calculate the area. We already have calculated from the diameter. Now we have to find out the stress value. Stress, as we know that stress F is equal to P by A. So P means the force 40,000 newtons and area is 314.16. So it comes to be 127.32 newtons per square millimeter. This is stress. And we know the equation. Strain is equal to delta L by L. That is also equal to stress by modulus of velocity. So first we'll, so delta L is equal to F into L by E. So here the elongation can be found by using this equation. Delta L is equal to stress into length by Young's modulus. So we are having all the values. So only thing is we have to substitute F value, L value, and E value in the equation. Then we can arrive the answer. The answer is equal to 0.382 millimeters because all the units are in newtons and square mm like that. So we are getting the elongation in millimeters. So the elongation of the rod in the given problem is 0.382 millimeters. So this is a simple problem. Next, we'll go to the another problem. So this is a different kind of problem as compared as that of the first one. Here we can write down this problem. First of all, a metal bar 200 mm long and cross section area 20 square millimeters carries an axial load of 5 kilonewtons, which produce an extension of 0.2 millimeters. Find the stress in the bar. and the modulus of velocity of the material. So here this is a different kind of problem. Here the cross section is directly given. So we will not bother whether it is a square cross section or it is a round section. We don't want. Directly the A value is given and the other values are given. Now we can write on the solution. First of all, given data, the length is given as L is equal to 200 millimeters and the area of cross section is directly given. We no need to calculate, and directly it is given as 20 or 25. In the problem they have taken the 25 square millimeters, and the load, axial load acting on the member is P is equal to 5 kilonewtons. That is 5 into 1000 newtons. So we have to convert that kilonewtons into newtons. Then the extension is equal to given as 0.2, delta L is equal to 0.2 millimeters. Now the solution. So we know that stress, first of all we have to find out the stress value. The stress is equal to P by A. The P is the force and A is the cross section area. So here they have taken the area is 25 square millimeters. So A by A, that is 50,000 by 25, will give the stress value that is about 200 newtons per square millimeters. That is the value of stress. Next, we know that strain is equal to delta L by L, that is the change in length by original length. So that is equal to change in length is given as 0.0, that is extension is given as 0.2 millimeters. And we got the original length of 200 millimeters. So 0.2 by 200, it comes to be 0.001. That is the strain. Now the modulus of velocity value can be easily found by the direct equation, as we know that the modulus of velocity is equal to stress by strain. Here the stress value we know and strain value also we know. So E is equal to F by E, that is 200 by 0.001. So E value is equal to 2 into 10 power 5 and the unit is newtons per square millimeters. So this is the modulus of velocity value, or it is also called the Young's modulus value. E is equal to 2 into 10 power 5 newtons per square millimeters. So this is the answer. The next one is the third problem we got. So it is a different kind of problem. A cast iron column is in the form of tube with internal diameter of 150 millimeters. What should be the minimum external diameter so that it may carry a load of 2 meganewtons without stress exceeding a value of 95 newtons per square millimeters. So this is the problem given here. So the problem given is it is a cast iron column and that is made in the form of a tube. A tube will have the internal diameter ID and the external diameter OD, that is outside diameter. So here the load is given internal diameter is given and the maximum exceeding stress is given, then we are supposed to find out the minimum, that is the external diameter of the column. So here the coming to the solution, the given data is given as small, that is internal diameter ID small d is equal to 150 millimeters. Axial load P is equal to 2 meganewtons. Mega means 10 power 6. It is a suffix in SI unit. So 2 into 10 power 6 newtons. And the stress induced is, that is in this case what is happening is the column is subjected to a push type force. A force is simply applied. So the member is subjected to the compressive force. So the stress induced is also compressive stress. So the given is a compressive stress and its value Fc is equal to 95 newtons per square millimeters. And we know that the stress is equal to P by A. So here the and A is equal to P by F. P is given and F is given. If we substitute the values, we'll get the answer as 2 into 2.105 into 10 power 4 square mm. This is the value of the area. Then after finding out the area, now our main aim is to find out the outside diameter of the tube. So let capital E be the capital D be the minimum external diameter of the column. So we know that the area, the formula for the area of the column is equal to pi by 4 into capital D square minus small d square. So this is the cross section area for a hollow tube. So we already found the area. So that area is equal to pi by 4 into that and here the term d square minus d square becomes 4 into a by 5. So it comes to be 26801.69 square millimeters. And here d square is equal to and one more thing, the small d also given as 150 millimeters. So the square of 150 becomes the 22,500. So when to get the capital D square, so we have to add this value to that value and we will get the capital D square value, and accordingly to find out the square root of sum of 26801.69 plus 22500 will become the 222 millimeters. So the outside diameter of the tube is equal to 222 millimeters. Okay, now we can go to the summary. So in this class, we have used some of the formulas as stress F is equal to load by area, that is nothing but the P by A, and strain is equal to delta L by L, that is E is equal to, and Young's modulus capital E is equal to stress by strain, that is F by E, and we got the Poisson's lateral strain, and that is equal to E dash by E, and so this is the assignment for the practice. And the second problem also, the next, so we can have some frequently asked questions in the examination. This is for the exam's point of view. So first of all, what is the formula to find out the stress? The stress is equal to P by A, force by area, P by A. The A can be found for the different geometrical shape. And what is the formula to find the elongation? We know that delta L is equal to force into length by area into Young's modulus. PL by delta L is equal to PL by AE. Next, what is the formula for the strain? Or write the formula for the strain. The strain is equal to delta L by L. The change in length by original length. Like that, we can find out. And in this lesson, so we have discussed about the mechanical properties, and we have defined the different properties like strength, modulus velocity, ductility, malleability, brittleness, hardness, resistance, toughness, and so on. And also we have understand the importance of the different properties while selecting a given material for a specific purpose. For example, to select the material to made a connecting rod, because the connecting rod is subject to the cyclic loads. So then it should have a more toughness and more fatigue strength. So accordingly, so while selecting the material for the connecting rod, then we should take these two properties. These two are the very important properties to be considered before selecting it for the application of a connecting rod. Like that. So different applications, for the different applications, the desirable properties are required. So we have to choose the materials which are having the desirable properties for the specific purpose, and accordingly only then we have to select. And afterwards, we already solved some of the problems, because also by solving these problems, we could become the familiar with the formulas, and we could able to carry out the stresses, strains, elongation, and also modulus of velocity. So like that, we have found, and we could become the familiar with the formulas. Now this is the lesson. So this is the lesson on the importance of the mechanical properties of the materials, and also we have worked out some of the basic problems to find out the stress, strain, elongation, and the Young's modulus of a material when it is subjected to different kinds of loads and having the different cross sections in the different conditions. So this is about the today's lesson. Thank you all. Thank you.